Welcome to Algebra 2, Unit 6, Lesson 1. This lesson is going to be on the classification and identification of monomials. Okay? A monomial, by definition, is an expression containing a constant, a variable, a product of variables, a product of a number and variables. So these are all examples of monomials right here. Right? Instead of spending all our time figuring out what is a monomial, let's quickly find out what isn't a monomial, because the list is much shorter. Okay? First of all, what isn't a monomial is a variable in the denominator of a fraction. So you cannot have any variable in the denominator because that variable could be a 0, making this entire thing undefined. Again, having a monomial inside the square root bracket or underneath the square root is also a violation because this variable could be negative and therefore making this particular statement undefined. Okay? The degree of a monomial is pretty straightforward. We simply add up all the degrees on the variables. So there is a 1 on the x, a 1 on the y, so the degree is a 2. Okay? We've got the degree of a 2 on that 4, a degree of a 4 on the x, and a degree of a 1 on the y. Okay, well, that is an exponent right there. It doesn't count because, well, 4 squared is 16, and so we don't have to worry about that. That's a constant. Okay, we only worry about the degrees on the variable. So that's a 4, a 1 adds up to a 5. Okay, and again, don't worry about the constant or the coefficient in front, just on the variables and their degrees. Okay, a 3, a 4, and a 1 gives us a total of 8. Okay, on this one, a 1, a 1, and a 5 gives us a total of 7. Okay, so let's check out this chart and see if we've got a monomial or not. Okay, quickly, let's just check, is it a violation? Variable on the bottom of a fraction? No. Variable inside the square root? No. So therefore it is a monomial. The coefficient in front is a 14, and the degree, a 2 here, a 1 here, gives us a total of 3. Okay, is this a monomial? You got a square root. Well, square root of 16 is 4. That works out, but wait a minute, the y is still underneath the square root bracket, so therefore it is not a monomial. Let's not worry about the rest. Okay, we've got a fraction. Okay, so we got to check, is there a variable on the bottom of the fraction? No, that's a constant, so it's okay. So this is a monomial. The coefficient, well, is 3 over 4 right there, and the degree is a 2 because we've got a 1 for the x and 1 for the y, gives us a total of 2. Okay, this one got another fraction, but this time we got the variable on the bottom of the fraction in the denominator. So therefore this is not a monomial. We're not going to worry about the rest. Okay, 22. Well, there are no variables. Well, is that a monomial? Sure it is. It doesn't violate the rules of a variable on the bottom of a fraction or variable inside the square root bracket. So therefore it is a monomial. There is no coefficient because there's no variable. Okay, and the degree is a 0. Okay, the degree of a non-zero constant is always 0 because I can say it's 22x to the 0 power. Okay, over here we've got 4 to the 3rd, a, b to the 9th, and, well, no fractions, no variables in the bottom of fractions, no square root. Okay, so therefore it is a monomial. The coefficient, well, let's work this out. 4 times 4 is 16, times 4 is 64. That's the coefficient in front of this. Okay, and we get a 1 on top of the a, 9 with the b, so that gives us a total of 10 degrees for this thing. Okay, this one right here, whoa, a radical sign, sorry, a square root sign. Therefore it can't be a monomial. No, it can, because what makes it not a monomial is if it's got a variable underneath the square root sign. This is actually a number. It's roughly about 2.44, I believe. So it is a constant. It is a monomial. There is no coefficient because there is no variable, but it's got a degree of 0. Okay. Next thing, combining like terms over here. Okay. Let's see, are these like terms? Well, we've got x squared y and we've got y squared x. Well, we can always use the commutative property of multiplication to rearrange the variables, and I always like to put them in alphabetical order. Okay. Well, that's got a 5, that's got a 1. We don't worry about the coefficients, we just worry about the variables to determine like terms. So yes, these two are like terms. Again, we've got xyz, xyz. Okay, don't worry about the coefficients, they are like terms. Okay, and again, right here, we got a squared b. Well, wait a minute. We've got the a's and b's here, but the exponents are different in both of these. So if they're not identical, they're not like terms. So we cannot combine them in any way. Right? Going back to this, let's see. We can combine all the x cubes. So we got negative 6 and positive 5. We add the coefficients, and we get a negative 1x cubed. Okay, x squared. Okay, 12 minus 9 gives us 3x squared. And then 7 and the 1, we add them together, we get the 8. Okay, in this one, let's combine all the m4, m to the 4th, b to the 3rd. We get m to the 4th, b to the 3rd. Okay, that's a positive 5 and a negative 5, so that cancels out, so we don't have to worry about that. Okay, now we're left with these. Well, wait a minute, they're not the same, but again, we're using the commutative property multiplication. I can move the b to the front of the m as b squared m to the 5th, b squared m to the 5th. Okay, so these are like terms. Positive 12, a negative 12 ends up being a 0. Okay? Properties of exponents. Okay? First of all, we need the same base. Okay, in order to be doing work right here. Okay. Rule 1, multiply the coefficients, keep the base, and add the exponents. All right. So in this one right here, we multiply the 4 and the 2, we get the 8. We've got the same base, so we just go ahead and add the exponent. The 3 plus 5 gives us an 8 right there. Okay. Second example. Okay. We multiply the 1/2 and the 6 to get the 3. Multiply the x to the 4th and x to the 1 to get an x to the 5th. A y to the 1 times a y to the 1 gives us a y squared. And there's nothing else to multiply with the z, so we just bring that z over here. Okay, so a couple of quick examples right here. Okay, again, we multiply the 11 and the 4 to get the 44. A to the 1st times a to the 3rd gives us a to the 4th. B to the 2nd and b to the 4th gives us b to the 6th. C to the 3rd and c to the 1st gives us c to the 4th. And d, well, there's nothing else to multiply here, so we just bring the d over there. Okay, and we can go ahead and put the little multiplication dots in between. Okay, so here's the rule. If we've got the same base, we simply add the exponents. So this would write as a plus a to the m plus n. Okay, again, have the same base. It doesn't matter if the base is a variable or if it's a constant like this. Okay, we simply add the exponents. So 4 plus 2 is 6. Okay, now we get tricky. Okay. We've got x, and x, so the bases are the same, so we know, and we're multiplying, so we can add all the exponents. Well, we can say k plus 2 plus 3k, and we combine like terms. K plus 3k gives us 4k, and the plus 2, so this is our final answer. Okay. The product to a power. Okay, when we have parentheses and we've got an exponent on the outside of the to the parentheses, we take that exponent and multiply it to all the exponents inside. So the 2 has a 1 as an exponent, so we go take it. 4 times 1 is 4. 4 times 3 is 12. So 2 to the 4th power is 16, and x to the 3rd times x to the 4th is x to the 12th. And again, we take that 3, and we take it 3 to the 1, so that becomes 3 to the 3rd, which is 27. Okay, and there's a 1 on top of the x as well right there. So 3 times 1 gives us 3. 3 times 2 gives us 6 right there. Okay, so the rule is this. We've got an n variable on the outside, and we got this, so we just simply go ahead and multiply right here, m times n, okay, and 2 to the nth power. Next thing, so we've got, again, we can write this out twice and go ahead and multiply like we would, or we can just simply use the product power rule. We take 2, and we've got a 1 on the 4 right there, okay, and now this time we actually take the entire negative sign with the 4, and we take that, so negative 4 times negative 4 gives us a positive 16, and now when it's with variables, it's pretty easy. Okay, 2 to the x squared times 2 gives us x fourth. Okay, 3 times 2 is 6. 2 times 5 is 10. And again, we take this, it's the power, we multiply it to that exponent, gives us 3x right there. We're taking this, multiplying with this, right? So I can say m to the first times m squared. It gives us m to the third. So that is now our new exponent on top of the base, which is an x. Okay. This one, this is the original exponent, taking it to the power. We multiply these two, so I wrote it like this. And if I multiply them, I get 2n squared plus 2n. Now sometimes you're going to have to take a couple of steps. First, we're going to go ahead and take this exponent of 2 and go ahead and raise everything to the second power inside. So I'm going to do that step by step. Okay, the 2 goes to the 1, and it goes to the 4 right there. Okay, so I go ahead and get 1 over 16. Okay, the 2 and x to the third gives us x to the 6th. And again, there's a 1 on top of the y right there. 2 times 1 is 2. Okay, we do the same thing over here. We get 3, take it to the 2 and also to the 3. Okay, so 2 to the third is 8, 3 to the third is 27, and because this is an odd exponent, that negative sign stays there. If it was an even exponent, we'd get rid of it. Okay, now we go ahead and take it to all the variables. Again, we always put an exponent. If there's not one, we always put a 1. Okay, so 3 times 1 is 3. 3 times 4 is 12. Sorry, I moved it to the back. I was wondering where it was. And 3 times 5 gets 15. I went ahead and put it in alphabetical order just to make it a little bit easier. Now I can go ahead and multiply. Since we're multiplying, we're going to go ahead and multiply the coefficients. We get 1 times 8 is 8. 16 times 27 is 234. 32. 432. And again, it's negative. And now we've got this, and we simply go ahead and add the exponents because the bases are the same. 6 plus 3 is 9. 2 plus 17 is, 2 plus 15 is 17. And the z, there's nothing to multiply here with the z, so we just bring that straight down. Okay. And finally, we have to go ahead and simplify this as much as possible. Okay. There's nothing else to do. We simplify this to 1 over negative 54. This problem right here, we're going to go ahead and multiply all these together, multiply this together, and then finally at the very end, subtract them. So let's work on this side first. I'm going to take it step by step. I'm going to take that 2, distribute it in. 2 to 3 squared is 9. That becomes a to the second, c to the 6th. There's no powers over here, so I just rewrote everything. Now I can go ahead and combine everything. 9 times 2 divided by 6 is 18 over 6. A squared becomes a4. Okay, b to the first, b to the fifth becomes b to the sixth, and c becomes 8. Okay, we reduce down to this. When I do the same process here, I ended up with this, and I put it in alphabetical order. Now we just go ahead and simply work with the coefficients. Once we've got like terms, we just subtract the coefficients. I get negative 1. Okay. Finally, we're going ahead and working on finding what's missing. So if I'm adding two things together, I have to know that they have to have the same bases, right? So it's got to have an x to the third, and it's got to have y squared. So in order for us to combine them and make them like terms, well, it's got to have an x to the third, y squared. Okay. This one, the bases are all the same. So we go ahead and add the exponents. 1, 5, 1, and 4 gives us a 10. Okay, and this one is, well, x to the third times something gives us x to the 7. So what could be in x to the what could make it a 7? Well, if that's an x to the fourth, then we get a 7. Again, over here, we just simply multiply the coefficients, multiply the bases here. We get 1 and a 3 is a 4. A 5 and a 4 is a 9. Okay. Again, we can go ahead and do this. Negative 5 times negative 4 gives us the positive 20. X squared times x to the third gives us the 5th. Y to the 1th times y to the 7th gives us the 8th. Okay, and we're going to go ahead and distribute, get this one. Okay. And what could I put in here? 3 to what? If I multiply 3 by what gives us the 15? Well, 3 times 5 gives us the 15. 3 times 2 gives us the 6. This one, the perimeter, we're going to go ahead and add all three of these things together. Right? If we have to add them, well, we know that this x, in order to make it like term, it's got to be an a squared b. A squared b right there. Okay. Well, 4 plus 7 gives us the 11. What else do I need to make it an 18? I need an additional 7. So this x is equal to 7a squared b. Okay. In this one, we are finding the area, so we're going to multiply the two things. And we know that the answer has got an a to the 7th, b, and c to the 5th. Okay. And it equals 42. So 6 times what equals 42? 6 times 7 equals 42. Okay. B times what equals, it's b. Well, it's got to be b times b to the 0 power, because if I add the exponents, I get a 1. C times what equals a 5? Well, c cubed times c squared gives us the 5. And again, we do not need to keep that b to the 0, so I can just go ahead and simplify and write it like that. If you have any questions, please come see me in class, and we can answer them.